Hello everyone, welcome to Basic Electronics Tutorials. In this video, I'm going to take up the first numerical on bridge rectifier. Let me read out the question first. A 10 kilo ohm load is fed from a bridge rectifier connected across a transformer secondary whose primary is connected to 230 volt 50 Hz supply. The ratio of number of primary turns to secondary turns is 2:1. Calculate Part 1 DC load current, Part 2 DC load voltage, Part 3 ripple voltage, Part 4 peak inverse voltage rating of the diode. Right, let us start with the solution part. Let us start by first writing down the given parameters. We are told that there is a 10 kilo ohm load. So the load resistance RL is 10 kilo ohms. Then the transformer primary voltage is given as 230 volt, 50 Hz. Please note this is the RMS value of the primary transformer voltage. Further, we are told that the transformer turns ratio is 2:1. The transformer turns ratio is given by N1 divided by N2, and we are told this is equal to 2 divided by 1. We know the transformer turns ratio and voltages across the same are related by N1 by N2 equal to Vp divided by Vs. Here Vs is the secondary transformer voltage. Since we know the values of N1, N2 and Vp, let us rewrite the equation and find Vs. N1 by N2 is 2 divided by 1 and Vp is given as 230 volt. Please note this is the RMS value and we will rewrite the equation for Vs. So the secondary transformer voltage is 230 divided by 2, which is equal to 115 volts. With that, now we can start the solution for the part A of the question, which is to find the DC load current. The DC load current for a bridge rectifier is given by the equation IDC equals 2 divided by pi multiplied by Im. Let me call this as equation 1, where Im is the secondary transformer maximum current. And it is given by the equation Im equals V secondary maximum divided by RL, where VSM here is the secondary transformer maximum voltage. VSM is given by the equation root 2 multiplied by Vs, where Vs is the RMS value of the secondary transformer voltage. We have computed Vs previously and it is equal to 115 volts. So let us substitute that here and find the maximum secondary transformer voltage. So it is equal to 162.6345 volts. Let me come back to the equation for Im. I'll call this as equation 2. Now that we have computed VSM, let us substitute the same into equation 2 and find Im. So Im is equal to VSM divided by RL. VSM we just computed, which is 162.6345 divided by load resistance, which is 10 kilo ohm. So this is equal to 16.2634 into 10 to the power of minus 3 amperes. This is the value of maximum secondary transformer current. Once we find Im, we can now substitute the same into equation 1 to find the DC load current. I'll rewrite the equation for DC load current here. This is equal to 2 divided by pi multiplied by 16.2634 into 10 to the power minus 3. Solving this will give the answer as 10.3536 into 10 to the power of minus 3 amperes. This is the value of the average load current. Well, that is the answer for part A of the numerical. Coming back to part 2 of the numerical, we are asked to find the DC load voltage. This one is pretty simple because the equation for this is simply IDC, which we just calculated, multiplied by RL. So, VDC is equal to IDC multiplied by RL. IDC is 10.3536 into 10 to the power of minus 3 and RL is 10 kilo ohms. So, the solution to this is 103.536 volts. That is the solution for part 2 of the question. Coming back to the question, let us now move on to part 3. In part 3, we are asked to find the ripple voltage. Ripple voltage can be calculated using the formula ripple factor multiplied by DC load voltage. VDC we have just computed, which is this one, and the ripple factor for a bridge rectifier is 0.4834. Let me call the equation for ripple voltage as equation 3. So, the equation 3 now becomes ripple factor, which is 0.4834 multiplied by VDC, which is 103.536. So, the answer for ripple voltage is 50.0493 volts. That is the solution for part 3 of the question. Lastly, coming to part 4, we are asked to find the peak inverse voltage rating of a diode. This one once again is quite straightforward because the peak inverse voltage rating of a diode in a bridge rectifier is simply equal to the maximum voltage across the secondary of the transformer, which we computed previously and is equal to 162.6345 volts. As I said, this is VSM, which is the maximum secondary transformer voltage, and is equal to 162.6345 volts. That is the answer for part 4 of the numerical. Well, with that, we have come to the end of this video. If you like this video, kindly like and share this video and subscribe to my channel for more tutorials on basic electronics. Thank you for watching. Have a good day.